Hi, welcome everyone. I'm going to take you through a course on blockchain. It's a 7-week course, and I'm going to take the next few minutes to discuss the contents of the course, followed by a simple demonstration of what is going to be covered, the key topics and the main topics, so that you get a glimpse of what we are covering in the course. So first thing is, it's a 7-week course. We are going to divide this course into 3 parts. The first part is going to talk about cryptography, modern cryptography in the context of blockchain. Now this is important, although you don't have to be a cryptographer, but very important to understand the concepts or the real strengths of blockchain and where does it lie. Now, followed by that, we are going to divide this into 2 parts. We look at a permission-less blockchain, such as a Bitcoin. Why we have taken a Bitcoin is because it is the most popular blockchain, the original blockchain successfully implemented. And secondly, there is good amount of material available. If somebody wants to experiment something on Bitcoin, then those materials are available. So that's a good starting point. And the final part of the course would involve a permissioned blockchain. What we are taking up here is Hyperledger Fabric. So we look at the concepts and the construct of Hyperledger Fabric blockchain. It's an enterprise-grade blockchain. We're going to discuss what is permissionless and permissioned, and then how this is different from a cryptocurrency or a permissionless blockchain. So this is what the overall objectives are. So we'll look at modern cryptography, we will look at introduction to cryptocurrencies, we'll have an introduction to blockchain, we'll take up Bitcoin and look at the architecture of Bitcoin in a little bit more detail. We'll look at the transactions within the Bitcoin, what makes up a particular a Bitcoin transaction, what are the components that go inside it. How do you create a simple wallet? What kind of scripts are available in Bitcoin, and how the Bitcoin network is established, how the transactions are transmitted from one node to another node in a peer-to-peer network mode. All these aspects we will examine in much greater detail throughout the first or the second part of the course. Finally, when we get into the blockchain, we are dividing the blockchain into the introduction to Hyperledger, and then wherein I'm going to give another breakdown of all the detailed contents of the components of the Hyperledger. We'll look at some of the key terminologies. We'll see how consensus is built in Hyperledger versus how it is done in Bitcoin. We look at the transaction in detail, what kind of assets are we can create in a Hyperledger. So we'll look at all the technical aspects of it, followed by Hyperledger Playground. Its Composer Playground is something that is available through IBM Lumix. We'll open that Composer, we'll run some of the sample applications, and try to build a simple application by ourselves, upload that on the Composer and see how it behaves. And finally, what we will do is we will build a Hyperledger application on our client. We'll download the Hyperledger Fabric and the Composer, build a very simple application, and see how we can deploy the application on the network. So that would be the end of the course. It's a 7-week course, roughly about 30 to 32 hours. And throughout this course, we will have a lot of architecture and design aspects being covered, which is really fundamental to blockchain. We all know blockchain is not a programming language, so it's not that we can start off coding something right on day one. We need to understand what we are going to do, and there needs to be a context of use case when we do some coding. So we are going to build a use case, and we are going to look at many use cases first of all, and then build one of them over a period of time, and on the final day we will be able to run that application. So that's how the program is structured. I'm going to take you through some of the some glimpse of what we are going to do in detail in our course. So we'll start off with what is a blockchain. So let's look at it. There are many definitions of blockchain. I mean, there are various ways of looking at it. But if you want to simplify it a little bit and say it in two words, one of the best definition would be it's a distributed consensus. What does this mean? The issue of decentralization has been a problem for quite some time. I mean, we all have or must have heard of Byzantine generals problem, and a lot of solutions have been developed over a period of time. None of them solve the problem completely. The issue is like this: you have a decentralization of data. If you have such a decentralization, then how does it ensure that the data integrity remains and the data is acceptable as a source of truth for most of the people who want to consume the data? The reason why this becomes decentralization becomes important is in today's world, centralization means that there is a central server where you need to create a trusted environment for the audience or whoever is consuming your data, and then if there are some disputes in the source of truth, then resolution of those disputes are difficult to manage. So how does distributed consensus help? What we are saying by distributed consensus is you move your data across all the peer-to-peer network nodes, and in such a way that most of the peers agree with the data, which means that the source of truth is agreed by everyone or most of them. Now, why I keep saying most of them is because a typical problem of all nodes agreeing is not possible. So there are some practical solutions to these problems, which is if a large number of nodes out of the total number of nodes that are available, if they agree to the source of the truth, then that solves the problem. So distributed consensus is one way of looking at what is a blockchain. If you look at the technology itself, there is a different way of looking at what's a blockchain. The technology is very simple. It's driven by mathematics. You have cryptography, which is the core of the blockchain technology. What cryptography does is it creates a immutable, incorruptible system of records for us. So blockchain is a system of record. That's the second definition. And this is created by cryptography. So any transaction that you do, and the transaction could be exchanging value of an asset. That asset could be a currency, or it could be any other information required by any parties. It could be public or it could be an enterprise. So coming back, any asset or value that needs to be transacted and tracked is created as a transaction in blockchain. A series of such transactions are built together to form a block. A block is nothing but a group of transactions which are chronologically added one after the other. And then you link these blocks with the previous block to create a chain. So hence blockchain. So this is the second definition. The first definition was around distributed consensus. The second is around the technology itself, wherein you have a transaction, you have blocks, and you have a blockchain. So finally, there is another way of looking at it. Blockchain is also very similar to cloud computing. What's a cloud computing? Yes, it's an internet-based computing. It uses shared resources. Blockchain does the same. It has got shared resources called peer nodes. So that's another way of looking at blockchain. The important distinction between cloud computing and blockchain is the decentralization of data. Well, decentralizations are also done in cloud computing, but the way they are done it in blockchain is slightly different. So we have different ways of looking at blockchain, and all these ways of looking are valid. All of them are important, because what we essentially plan to do with this technology is change the way we do transactions, change the way we track things, change the way we want to evolve the internet applications down the line. So, let's discuss the evolution of blockchain a little bit in more detail. This will give us an idea of how blockchain is currently reached this stage and what can be the possible future for blockchain. So let's start with 2009, where the first experiment of blockchain through a white paper was developed. It was the Bitcoin. 2010, Genesis block of Bitcoin was mined sometime in January. This you can call it as blockchain probably 1.0. This was the first successful experiment, not successful in 2009, but successfully started in 2009. And it continued until today. So let's look at what happened in between. Around 2011, the first other cryptocurrency called Namecoin was forked from Bitcoin. So somebody looked at Bitcoin, it was a cryptocurrency, and thought that okay, we can make some more currencies, but with a slightly different variation or a slightly different use case. So Namecoin was created in 2011. After that, there were a lot of early cryptocurrencies that came about between 2011 and 2013. But then 2013, a proposal was made that let's convert the blockchain technology not just for the currency use cases, but look at it from a larger perspective, which is, can we use blockchain to create something called as a smart contract? Now, smart contract is an entirely different discussion altogether. It has been in existence for quite a lot of time. All it means is your contract clauses, terms and conditions, whatever you see when you're signing some documents, are codified in computers. So that's smart contract for you, contract which is codified in computers. Although people have been trying to work on smart contracts, and there are a lot of ERPs which work on contracts. This one used the concept of immutability and incorruptibility of a blockchain, which comes from the cryptography. So it uses these concepts to build a smart contract. This was a paper proposed on Ethereum way back in 2013. Now this raised a lot of interest in general industry, and a lot of cryptocurrencies started flooding in the market between 2013 and 2015. And of course we know that there were a lot of consortiums. There was an R3 consortium that came up from the financial industry. Financial industry was the first to pick this up. Between 2013 and 2015, a lot of cryptocurrencies flooded the market. Along with them came certain consortiums from the banking and the financial industry to get together and create a blockchain specifically to solve problems around the supply side of financial derivatives. By the same time, around 2015, Ethereum, which had proposed a white paper in 2013, had come up with their first currency called Ether. And it had a blockchain based smart contract on it. So this is where things started taking turn for use cases which are other than cryptocurrencies. A lot of use cases came up. Hyperledger was something that started in December 2015. The attempt was to create an enterprise grade blockchain such that anybody, any large organization which need some of the core strengths of blockchain, they can use an enterprise grade blockchain, and the core strengths being incorruptibility and immutability of data. So Hyperledger came in as an enterprise grade blockchain in 2015, and it continues to grow. There are a lot of Hyperledgers. Fabric is one of them that we are going to take you through this course. and followed by a lot of companies which are now looking at giving blockchain as a service, or BaaS, as a platform for smaller enterprises, small and medium enterprises, public and even large enterprises to be able to create applications on blockchain technology. So this is how it has evolved so far. Where it's going to go from here? The potential is very high. There are lots of use cases that are being talked about. However, we don't know how many of these are true use cases yet. But there's no dearth of experimentation. People are experimenting in various ways, and hopefully we will all know what is or what are some of the best use cases once they are implemented and are successful. Okay, so in this part, we will look at a little bit on technology of the blockchain, how cryptography helps and how transactions and blocks are built. To give you an idea, there are something called as hashes in cryptography. Hashes are one-way trapdoors, which means that you can take a large amount of data. Let's say you have a big data, like a contract, which is worded. You compress that and create a message digest out of it. And that message digest is a very small number. The true capability of a good hash would be that, when you take up a large data and you compress it, the data that results, which is called as a hash digest, cannot be used to recreate the original data. That's the fundamental. The second part of it is that you cannot create the same hash using two or more different sets of data, which means that one result is because of only one input. It cannot be that there is another input which you can tweak a little bit to arrive at the same result. So given these properties, and there are a couple of other properties of hash, given these properties, how do we use hashes in blockchain is something that we learn. The second part is something on the encryption and digital signature. Now, cryptography has typically three parts. You have encryption of data, you have authentication, and then you have digital signature. All the three are important. Out of this, of course, most of the currency uses their own cryptographic scheme. We will look at elliptical curve as the scheme because that's the one that used in most popular blockchains today. So we will look at what is ECC curve. We will look at the scheme of encryption. We will look at how authentication is done and the significance of digital signatures in blockchain. Now this is a very important concept because this is what gives a lot of the properties of immutability, incorruptibility to the blockchain. Once we understand the hashes and the cryptographic schemes, then we can actually look at how a transaction is built in blockchain. So let's say you have a transaction which contains some data. Okay, for example, in Bitcoin it would be the Bitcoin data itself, the owner of the Bitcoin, public address of the person who is owning. What I mean by owner is that. In case of a typical blockchain, it could be an asset. For example, you have the temperature of a storage which you want to track. That is an asset and that's a data. So you want to store that data inside your blockchain. In case of Bitcoin, it's a currency. It can be anything else outside of Bitcoin or outside of cryptocurrency. So when you want to store such a data, you need to create a transaction for that. So how is that transaction built? You always start with a genesis transaction or a create transaction, which means you are creating the asset for the first time. When you create an asset, you need to have certain privileges to create that asset. And once those assets are created, the life cycle of the asset is tracked through this blockchain technology in a way that I'm going to explain now. So what happens? You created an asset and you want to now change the value of the asset. For example, you've been moving on a cold storage, certain item, and then you want to track the temperature. And let's say the temperature changes from, say, 3 degrees to 4 degrees. Now you want to track that. What you do is you take up the original transaction which had recorded the temperature as 3 degrees and then reference this transaction to create another transaction and say that at this point in time the temperature was 4 degrees. So by referencing it, what you are doing is, and what you reference here, by the way, when you create a transaction for 3 degree, you would have created something called as a cryptographic hash. We talked about it. The hash is a unique number, and any changes in the transaction post facto will change the hash as well. So what blockchain does is it records the transaction hash, and this transaction hash is used in the next subsequent transaction. So from 3 degrees to 4 degrees, a change in temperature that needs to be recorded. The new transaction will have cryptographic transaction hash referenced from the previous transaction. So this is how the transactions are linked together in such a way that nobody can change the transaction once it is recorded in the system. Now, where does block come here? So once you have the transaction, typically you pick up a lot of transactions, group them together and call it as a block. And this is done only for efficiency. You group things into a block. Again, blocks have something called as a cryptographic hash, okay, which is the hash of the entire contents of the block. Say there are 10 transactions that you want to record in a block. Put all the 10 transactions together, create a cryptographic hash and give that name as a block hash. Now the next block that you're going to create will reference the hash of this particular previous block and thus create a chain. Now by doing this, it's a smart way of doing it, and by doing this what we are ensuring is that a transaction can be referenced to any transaction that is done previously, and we also know the sequence in which the transactions were created because the blocks are also referring to one block behind. Now with these two simple techniques, the entire blockchain is built. And then the third part of the equation is how do you ensure that the data is distributed widely? That's through a peer-to-peer network. We'll look at the various ways cryptocurrencies do that and various ways in which enterprise-grade blockchain could do that. Now once these are done, then the final part of this entire blockchain would be to see whether all parties agree to that blockchain data. And how do you do that? That is something through a process called consensus. In a typical cryptocurrency, for laymen, we might have heard of miners who are mining the bitcoins or any other cryptocurrency, and they are the ones who actually try to build consensus by doing certain actions. What actions? We will look at those actions in detail during the course. But if you look at, on the contrary, permission blockchain, which is run by an enterprise or a group of enterprise or an industry as such, the stakeholders there are slightly different. It's not public, so you need to be able to give a certain access to certain stakeholders, not to everyone, not general access. Hence, the consensus building mechanism is going to be slightly different in case of a blockchain, which is enterprise blockchain. So we are going to look at that as well. And then we will also see how to deploy an application, what kind of use cases. The most important part of this entire discussion is what are the use cases that are typically going to fit a blockchain. We can create anything, we can create an entire ERP out of it, but what we need to understand is what is the most important use case that takes the strengths of blockchain into as its core and then builds on that. So we are going to look at all those kind of use cases, and then we'll probably build a very small use case to get hands-on practice for everyone, and then you can continue experiment on your blockchain journey. So this is what we are going to cover in the course, and hopefully this will help you in your career when you are looking for your jobs and you want to do something new, something exciting that's happening in the technology space. This is the right course for you. So here we are. This is the Hyperledger Composer that is used, built by a consortium of team thanks to IBM. They have deployed this on IBM Bluemix, and we can go and access that Composer playground to play around and create some minor applications. What you see here is a web version of it. Now this is not the end result of our course. What we are going to do is we'll look at this Hyperledger Composer and on the web version, deploy some small application, play around with it, get a feel of what kind of applications, how the applications are created and deployed. And then finally what we are going to do is download the Hyperledger Fabric itself on our laptops, download the Composer on our laptops, and then deploy this particular application, whatever we are going to create, for transactions. That's the client version. So what I'm showing today is just the demo, just to get you into it, some feel of how the Hyperledger Composer looks. So to begin with, just this is all publicly available URL. You just go there and log in. If you click on the Get Started, it will get all the sample network. There are some sample network applications that are already built and they have been given as a part of the demo. So there are many sample applications that are there. If you want to test it, you can test them. Now, there is some small library here which tells you how this entire composer is deploying the application. You can see that here. Now, when I take up the actual course, I will give details of who are the participants, what is an asset, what is a transaction, what are events. Now, in addition to these simple concepts that we are going to look at, certain things like the internals of Fabric, which has components like channels, components like orderer nodes, components like endorser nodes, and the entire mechanism of how transactions are built, validated, and created into a distributed ledger, and then finally published into a blockchain. So we are going to look at all of them. But as far as the composer is concerned, if you want to create a small application, say transferring asset from one owner to another owner, it's not very difficult. As far as the composer is concerned, you can play around with it and get some feelers around it. So for example, you have the model file here. This model file gives you the simple definitions that you can create, what kind of data that you're going to use, and whether they are strings or enum. You define your data set right here in the model file. Once you define your data set and business network in the model file, you can write the script. The script is where the business logic resides. In this script, you put your own business logic. For example, we'll create a small application wherein we say that, okay, A can transfer asset to B provided certain conditions are met. And those conditions are business logic, which we are going to code here. You can use JavaScripts to do that. If you don't know JavaScript, that is also okay. This course is not meant only for programmers or developers, also for architects, designers, and business analysts. So don't get too worried if you see a lot of coding. What we will do is we will provide you with some basic coding, and then you can run your applications on Hyperledger. But you will get to do it hands-on. So this is the business logic part. Finally, we have the access control, where we are going to define who is going to access what. This is standard. We'll look at that in a little bit more detail when we get into the actual course. Now this is the definition part. You can create your Hyperledger small application from here and deploy it, and then if you want to test it, you can test it here. So let's look at what kind of testing we can do. Now first of all, we'll see our business networks. I'm trying to deploy a sample business network, and these are all samples that are available. I'm not going to create anything new here. I'll pick up something called car auction network. And say deploy. Now here we are, car auction network. If I connect to it now, the same fields, the same page comes up, but this one is an application by itself. Previously it was a sample file. So if you look at the model here, you will see a lot of sample assets that have already been created. We can go through them. We'll see how to construct such a sample asset down the line. And then we also have the business logic for car auction, and these business logics are part of the sample application. If you want to test it, you go to the test application and start doing it. So you can create participants. It's a simple UI that is given. A participant ID and all is generated automatically. So you can give your name here, for example, and say create new. What this is doing is actually creating a participant in the network for you. So participants are like, in case of Bitcoin, if I have to give you an analogy, it's everyone. Anybody can participate in a Bitcoin. In blockchain, it will be slightly different. Now, you can create a sample asset. For example, your asset is a car, and each asset is has an ID here. The ID is 0368. I can create a value for it and say my car is worth 100. Just trying to give you a feel of it. And then you can look at all the list of transactions that I did today. So this is what blockchain does. Now, Composer is highly abstracted. What it does is it looks at the entire blockchain, all the asset creation, sample, participant creation, all of them have gone inside the Hyperledger Fabric blockchain as transactions, and they have been built in as a block. Now, what you see on Composer is an abstracted version of it. So it basically picks up what is the most important things and gives you a record of what you did. So I added an asset. So I started off, I didn't take any action here. It says here I added a participant as an admin. Here I added an asset as an admin. Anything that I do is recorded here, and it is linked back. So addition of participants and assets would probably be a part of one single block. And if I change the asset ownership from participant A to participant B, that is a transaction which is going to reference back to one of these transactions where I created the asset. So we are going to look at all of this in much larger detail when we get into the course. This is just a glimpse of it. You can submit a transaction, and there are various transaction types that you can define. Now here is just a sample transaction. All it's asking is give me a new value, and I'll say 1000 is my new value for this asset. Of course, I have to get the asset number. So this asset does not exist because the asset ID is different. So all we do is go back, get the asset ID, which is 0368. And when I submit the transaction, I'll say asset is 0368, and I'll say new value is 1000. So it has recorded this transaction successfully, and when I look at my transactions, it says that there is a sample transaction which I executed, and the values would change. If you look at the asset as such, the value which was 100 earlier has now become 1000. So Net, if you see, there is hardly any beauty that you understand by looking at this application, but the beauty lies in the fabric model, and that's what we want to explore when we get into the course. This is just a front-end view, and it helps you to get a feel of how assets are built, how transactions are done. So I hope this was helpful for all of you to. These are publicly available. Just go ahead and play around and look at how this thing works. And then for more details, of course, you have the entire course content, which will take you through all the aspects of it.